I am Subbalakshmi. In the last video, we have discussed about mole concept and Avogadro's number. So now you know what is a mole, the mass of one mole of any substance, and the number of entities present in it. Then what about the volume of one mole of any substance? The concept of molar volume explains it. Molar volume is the volume occupied by one mole of any substance in the gaseous state at the given temperature and pressure. Is it essential to state temperature and pressure? Yes, it is. Then why? To answer this question, let us take the simple example that all of you would have come across. For smooth riding and handling, air pressure of the tire is important whether it is a bicycle or car or any other vehicle. A drop in the temperature causes loss of pressure in the tire and it is to be checked. Now you would have understood that it is important to state the temperature and pressure. The volume occupied by one mole of any substance in the gaseous state at STP is 22.4 liters. STP is the standard conditions of temperature and pressure, that is 0 degrees centigrade or 273 Kelvin and 1 atmosphere pressure. 0 degrees centigrade is exactly equal to 273.15 Kelvin. At NTP, it is 24.04 liters. NTP refers to normal temperature and pressure, that is 20 degrees centigrade or 293.15 Kelvin and 1 atmosphere pressure. At SATP, it is equal to 24.8 liters. SATP is standard ambient temperature and pressure, that is room temperature or 25 degrees centigrade or 298.15 Kelvin and 1 bar pressure. Let us work out some exercises. Question number 1. Calculate the number of entities in 450 ml of the gas at 273 Kelvin and 6 atmosphere pressure. In this problem, the volume of the gas under a given set of conditions is mentioned in milliliters. This is to be converted into liters, which comes to 0.45. The first step is the calculation of N, the number of moles. You know very well that if the volume is 22.4 liters at 273 Kelvin and 1 atmosphere pressure, then the number of moles is equal to 1. If so, then what is the number of moles under the given set of conditions? 273 Kelvin, 0.45 liters volume and 6 atmosphere pressure. Writing the steps and calculating, we get the answer that N is equal to 0.12. Having calculated N, we can calculate the number of entities, that N is into Avogadro is number, which gives the answer 7.23 into 10 raised to the power of 22. This is the number of entities present in the gas under the given set of conditions. Question number 2. Calculate the number of water molecules in 100 grams of it. This is the first part of the problem. The first step is the calculation of the number of moles. The substance mentioned in the problem is water and its mass given is 100 grams. Therefore, the number of moles is equal to 100 grams divided by 18 grams per mole. Then, substituting in the formula that the number of molecules is equal to N, the number of moles, into Avogadro's number, that is 100 grams divided by 18 grams per mole into 6.022 into 10 raised to the power of 23 gives the answer 33.46 into 10 raised to the power of 23. The second half of the problem is what is the number of hydrogen and oxygen atoms present in it. Number of hydrogen atoms is twice the number of water molecules, since one molecule of water contains 2 atoms of hydrogen. That comes to 66.92 into 10 raised to the power of 23. whereas the number of oxygen atoms is the same as that of the number of water molecules, equal to 33.46 into 10 raised to the power of 23. Then question number 3, calculate the number of carbon dioxide molecules in 1 gram sample of it. How many carbon and oxygen atoms are present in that? This is similar to the previous problem and the same steps are to be followed. The first step is the calculation of number of moles, that comes to 1 gram divided by 44 grams per mole. Then substituting in the steps, we get the answer. The number of carbon dioxide molecules is equal to 0.14 into 10 raised to the power of 23. The number of carbon atoms is the same as that of the carbon dioxide molecules. It is 0.14 into 10 raised to the power of 23, whereas the number of oxygen atoms is twice the number of molecules of carbon dioxide. It comes to 0.28 into 10 raised to the power of 23. Question number 4. What is the mass of one molecule of carbon dioxide in grams? The given substance is carbon dioxide. The mass of 1 Avogadro's number of molecules, that is 6.022 into 10 raised to the power of 23, is 1 gram mole, which is 44 grams in this problem. If so, then what is the mass of one molecule of carbon dioxide in grams? Writing the steps, we get the answer that it is equal to 7.31 into 10 raised to the power of minus 23 grams. Solving this problem helps to differentiate between the mass of 1 mole of any substance and the mass of 1 molecule of it. So in this video, we have discussed the concepts of molar volume and worked out problems which are solved by the combined applications of mole concept, Avogadro's number and molar volume. If you find this video useful, then share with your friends and subscribe. Let us meet in the next video to discuss some more basic concepts of chemistry and chemical calculations. Thank you very much.